Just going over exercise 6E, question D, E and F. Now there's the question here, and I've just redrawn it very, very strangely over on this side. Now there's no two lines over here, so I can't always tell whether it's the same as these two with the actual two lines. I'll just get rid of those because they shouldn't really be there. However, I've just noticed, it took me a little while, that you know that if this side is 20 and this side is 10, then this side here should be whatever is left over from 20 take away 10, shouldn't it? Yes, it should, miss. Yeah. So this side here is actually going to be 10, isn't it? And if it's got two strokes, then this side here is also going to be 10, isn't it? Alright. So there we go. Now, I'm just going to go over this because there's actually two ways you can do this. You could either split this lovely one. So this is method number one. This is called the addition method because we're going to add two separate areas together. And then I'm going to show you the subtraction method. Alright, I'll leave it up to you. You should know these two different ways. Alright, so if you're going to do it the old way, what I would consider the old way, is you would first of all have a look at area 1 and you would say to yourself, okay, it's 20 by what? Now we already know this one here is 10, so that means if I go 20 of the top up here minus this 10, then this one down here must also be 10. So we know that area 1 is going to be 20 times 10, which equals 200. And it's in meters, and we're finding the area, so it's meters squared. And area 2 is this little one here, right? So that's going to be 10 by 10. Notice my working out, my sweets. Love to see some on your pages too. 10 times 10 is 100, and then we just add those two together, and our total area is, notice I'm writing little words so that I can understand exactly what's going on. You guys should start doing that too. And I get 300 meters squared. Now that's called the addition method because you're adding two separate areas together. You could also do what's called the subtraction method. So the subtraction method, I'll do it in blue, is you take the whole outside of this shape. So you take that big outside square. So this is method 2. So I'm going to work out that big square. Now I know that's 20 by 20. Would you agree? 20 by 20 gives me 400. And then what I do is, I'll do this in yellow, is I work out the area of this section. And what I'm going to do is I'm going to cut that from the main big blue rectangle, or in this case it's actually a square. So my second set of working would be 10 times 10. But this time, instead of adding, I would subtract, because I'm taking, I'll try and do this in a different color, I'm taking the big rectangle and I'm taking away that little yellow section. Alright? So that's why I'm subtracting. And if I do that, 400 minus 100 also gives me 300. Okay, so that's the subtraction method. Sometimes it's just a little bit easier. Alright, so next I'm going to do D, E, and here's E. Now sometimes, black pen please miss, so here's E, and I'm going to redraw it so I can write all over it. Stop moving. Bang, 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 bang. Shorten that a little bit. Bang. That's one good thing about these things, you can do that. Alright, so I know that this little section is 2, and I know this one is 5 and this one is 4. Okay, it's told me that these ones are all the same. Now basically you need to know that if you've got 3 sides, like those 3 sides, and they're all the same length, well then pretty much that one's going to be the same as well. So straight away that's telling me that all of these are 2. So hopefully you know, just make it a bit thinner, if this side is 4, then this side over here will obviously be, that will be 4. And if, I'll do it in a different colour, if this side is 2, Then this one and this one will be 3 take away 2 is, sorry, 5, my bad. 5 take away 2 is 3. Now, because there's 2 of them, you've got to split it in half. So that means that there is 1.5 and that there is 1.5. Now, quite frankly, if you do this the subtraction method, you don't have to actually split it up into 2. I'll show you. Alright, so 2 methods. If you were to do, I'm going to do the subtraction method in the addition method in black. So if I was to do the addition method, I'd probably split it up into 3. Now most maths teachers will say the more working out you do, the more likely you might make a mistake, but it's totally up to you. So area 1 has got one side that's 1.5, area 2 has got one side that's 4. Sorry. Area 1 has got one side 1.5, one side 4. So area 1 would be 4 times 1.5, wouldn't it? Area 2 is that little one in the middle. That's actually, let's see, if that's 2, then that must also be 2. So area 2 is 2 times 2. And area 3 is the same pretty much as area 1. So I'm just going to actually times that one by 2 because there's 2 of them. Alright, let's do them all on our calculator. Oh, can't see, it's getting so dark. 4 times 1.5 times 2 gives me, turn on your calculator, miss. Excellent. 4 times 1.5 times 2, pardon me, gives me 12. And 2 times 2 gives me 4. So here I add them together. Total area is 16, and that's in centimetres. So that's centimetres squared. Now if you want to try method 2, I'll do that in blue. So that's the subtraction method. So what you would do there, and I'll do it in blue pen as well, you would work out the whole rectangle. Now we know the rectangle is 5 by 4, so we would go whole rectangle, sorry I get very messy if I don't make it a bit smaller, is 5 times 4, which we know is 20. You're just looking equal signs. Okay, and then we work out the little square. So we're going to cut out this bit. Now I know that that square is 2 times 2, isn't it? So it's 4. So this time I'm going to subtract 20 take away 4 gives me 16 centimetres squared. So sometimes you're doing more working out for the addition method than you are for the subtraction method. Sometimes the subtraction method is just faster. Alright, now here's F. Okay, F looks like it's fun, doesn't it? F. Let's do that as quick as I can. I'm going to draw that one. Stop moving, please. Okay, alright, so I'm actually thinking the subtraction method is going to be faster for this one, because up here we have a trapezium, don't we? And it's going to be really fiddly, because you probably, if you do the other addition method, you'll probably have to cut it there and there. You're going to have to work out this, and you're going to have to work out this, and you can make a mistake if you work out a side incorrectly or you guess. So I'm actually going to suggest you do this one, the subtraction method. So the subtraction method is work out the area, make that a bit fatter, hey, of the whole outside this rectangle first, okay? So I know it's 6 by 6, don't I? So let's do that first. So I'll write that down. Notice I write whole rectangle, or just rect if you want, equals, so I'm writing down what I'm doing in case I forget later. So 6 by 6 is 36, so I'm going to do the subtraction method. Now I have a trapezium, don't I, in here, so I need to work out the trapezium formula. Now I need the far side, so let's see, I'll do black now. I need this side, which I know down the bottom of my diagram is 6. opposite sides of a rectangle, or in this case it's a square, opposite sides are the same. I already know this one is a 3, so they're my parallel sides. And let's see, I've already got my height because it's in there on my diagram, and it's 3 as well. So that's your A, that's your B, and that's your H. Okay, so area of a trapezium is H over 2, A plus B. Do we remember that? Okay, so let's have a go. So the height is 3, so I'm going to do 3 over 2, and A plus B is the parallel sides, 6 and 3 added together. Okay, so 6 plus 3 on my calculator is 9 in the middle, times by 3 over 2 or 1.5, whichever you prefer, and I get 13.5. So now I'm going to subtract those because I'm doing the subtraction method. 36 minus 13.5 gives me 22.5. 22.5 meters squared. Alright, let's try the next one. What did I say the next question was? 8 and 9, didn't I? 8 and 9 BGH. Alright, hopefully I've got some room. Alright, so now let's try question 9. Question 9 is over here. I'll make it a bit bigger. Now, whenever you get... oh no, that's 7 and 8, miss. Silly. Sorry about that. Here it is. Question 9. Oh, I didn't mean all of that. Did I say 8 and then 9? Sorry, 9. It's been a long day. Yes, I did. Sorry. Okay, let's try question 8, please. Question 8. Thought so. 20 circular pieces of pastry. So I need 20 circles. Each have a diameter of 4 centimetre. Alright, so I'm going to just draw 1. That makes more sense to me. So that's question 8, miss. So I've got a circle, but I've got 20 of them. Yeah? So I'm going to times by 20. And they've all got a diameter. So remember, diameter is straight across of 4 centimetres. They're cut from a rectangular layer of pastry. Oh, I used to do this with my mum many years ago. And the rectangular pastry, so see, notice I'm drawing a diagram, is 20 centimetres long and 16 centimetres wide. What is the area, correct to 2 decimal places, of pastry remaining after the 20 pieces are removed? Alright, so, operative word, 20 pieces are removed. So when we remove something, that's the subtraction method, isn't it? So that's what you have to do. You pretty much have to do the subtraction method. So let's work out the rectangular pastry first, because that's nice and easy. What's the area of a rectangle again? 20 by 16. Okay, I'm going to do that on my calculator. 20 by 16 gives me 320. I'll just write that here. And that's in centimetres, so it's centimetres squared. So here I've got 20 circles, don't I? So I have to do 20 times pi r squared. Remember, area of a circle is pi r squared. Do I have the radius in this particular circle? No, I don't. I've got the diameter, don't I? So I need to work out the radius. Radius is 2. So I'm going to go 2 squared. So on my calculator, I'm going to go 20 times pi times 2 squared equals 251. Did it say how many decimal places? 2 decimal places. 221.327 rounds up to 33. Okay, now if you're taking those circles out of the rectangle, what do you think you do to those two numbers? Hopefully you said you subtract them, miss. Beautiful, well done, year 9. So I'm going to go 320, take away, it's on my calculator, but I can't see it because it's so dark, 251, did I write that down? No, I wrote 221. I beg your pardon, that should be 251. Can't read my calculator in the dark. 251.33 equals Please tell me if I'm wrong. 68.67. I will just double check that, and it's in centimetres in case I did that wrong. So 20 times pi, no, that's not pi, miss. 20 times pi, yep, times 2 squared is 4, 251, yes, okay. So there you go, there's your answer. Let's try 9. Wait, let me find 9. 9, I said B, G, H. Alright, let's see if I can fit them on. Do I need some more paper? Ooh, not a lot of room, hey. So 9, B, G, H. Alright, I'll try B. Alright, what does it say? Find the area of the shaded region of each of the following shapes by subtracting. Good, okay, so we're going to do subtracting. Subtracting the area of the clear shape from the total area. Beautiful. Alright, I'm going to try and do these smaller because I'm running out of room. So here's my diagram. If you look at it, it looks like there's a trapezium, doesn't it? Yes, it does. So I'm going to do the outside shape first. So in green, the outside shape will be what times what? Hopefully you said 5 by 9 is 45. I'm going to try and get it all in here because that's the end of my sheet. Alright, and then the trapezium on the inside, I'll do that in blue, is half the height. Remember, the height is the distance from one parallel side to the other. These are the parallel sides, and the diagram is on the right if you're wondering where I'm looking. So I'm going to go 5 over 2 brackets, and you add the two parallel sides, 3 plus 9. If I do that on my calculator, 5 divided by 2 is 2.5 times 3 plus 9 I know is 12, so times by 12 gives me 30. Now I want, find the area of the shaded region, yep, so I want the two triangles on the end, so yeah, oh, this will do. Shaded, so that's these ones here. Shaded region, I have to subtract, will be 45 minus 30, which is 15, and that's in meters squared. So there's the first one. Alright, let's try G. Let's find G. Where's G? There's G. Good old circle. So here, what are the two shapes you have? Hopefully you realize you have a circle and a triangle. Okay, so let's work out the half circle first of all. So half a circle, normally the area of a circle is pi r squared, isn't it? Do I have the radius? No, I don't. I've got the diameter. How do I work out the radius? Diameter is 7, so radius is 3.5. So to work out the area of a full circle, I would do pi times 3.5 squared, wouldn't I? I don't have a full circle though, do I? I have half a circle. So let's work that out. Pardon me. A half times pi times 3.5 squared is 19.24. I'll just check. Is it to two decimal places again? Yes, it is. 19.242. So it's definitely 19.24. And that's in millimeters. And then we have a triangle. So here's our triangle. Now it's half base times the height, isn't it? Now the base and the height need to be, there we go, at right angles. Now I know there's a little right angle in the corner, but that little red line touches the 7mm line like a T, doesn't it? And if you can see a distinct T, that's perpendicular. Alright, T is also this particular symbol here. That's also a symbol that two lines are perpendicular. So the 7 and the 3, the 7 is the base, the 3 is the height. So a half times 7 times 3, so that's half of 21, isn't it? Is 10.5 millimeters squared. Now they want us to use the subtraction method, so I'm going to go half circle minus the triangle, so that's 19.24 minus the 10.5, and on my calculator that gives me 19.24 minus 10.5. Oh, and I just got rid of it. Yay! Oh, can't do anything today. Sorry. Minus 10.5 is 8.74 millimeters squared. And the last one, let's do H in a different color. Here's the picture for H. Ooh, now this is called, how much room do I have? I have a bit of room, hey? Okay, this is called an annulus. If you've never heard of this before, when you get to year 11 and 12, you might do it a bit more. But you'll do it again next year, don't worry about it. So basically what it is, it's like a donut. You've got a circle inside a circle. So the easiest way to figure this out is you're going to do the big circle, that's the big circle on the outside, and you're going to subtract by the small circle. And now remember, it's still area, so we're going to use pi, hello, there we go, pi r squared. So the little circle would be on the inside, and we would work out the big circle minus the small circle. Okay, so looking at the diagram, what's the radius of the big circle? That's 4, isn't it? And it's a full circle, so we're going to use pi times 4 squared. So let's do that first. So on my calculator, I'm going to do pi times 4 squared is 16. So I get 50.265. I'm going to do it to 2 decimal places. 50.265 makes 27, doesn't it? Beautiful. Now in blue, I'm going to do the small circle area. Small circle area, it's got a radius of 3, so I'm going to do pi times 3 squared. So on my calculator, I'm going to do pi times 3 squared is 9. That gives me 28.274. So to 2 decimal places, that's 28.27. Now, remember what I said? It's like a donut. So if there's one inside the other, to work out this bit, you have to subtract the 2 circles. So 50.727 minus 28.27 gives me 22, and that's in centimeters, and that's squared. Thanks to you 9. If you'd like to have a go at question 10, feel free, or even 11, they look like fun. See ya.